Hello, Mrs. Allison here, and today we're going to look at graphing polynomials using transformations. You did something similar yesterday, but I want to do one more example with you just to make sure you are good to go for the assignment for today. So here is our example, our equation, and we first want to identify the parent function of our polynomial. So in this case, we're going to look at the exponent, and our exponent is 3, which tells me then that my parent function is going to be x cubed. So we're going to write down our points that are associated with that x cubed function. If you don't remember them, not a big deal. You can use your toolkit and find your points associated with x cubed, or I can plug in the x values -2 through 2 and cube them all. And when I do that, I get -8, -1, 0, 1, and 8. Now that I've identified my parent, I want to determine my transformations. Okay, I have several things going on, and remember, anything inside is going to affect my x values. So inside here will affect my x's in the opposite way. So I'm going to add 1 to each of my x values. So -2 plus 1 is -1. -1 plus 1 is 0. 0 plus 1, 1 plus 1, and 2 plus 1. So there's my new transformed x values. And what I've done is I have shifted right 1. Next thing I want to look at are anything outside of my function or outside of the parentheses. In this case, I have a couple things going on here. I have that negative, which is going to be a reflection over the x-axis. Because it's out front, I'm going to change my y value. So I'm going to reflect over x-axis. That 2 out front is going to be a vertical stretch by 2. Okay, so I'm reflecting and stretching. And I can actually do that in the same step. In order to do that, I'm going to multiply my y's by -2. That will reflect and stretch them at the same time. And then don't forget this +4. This +4, because it's positive, will shift my graph up 4. And that's also affecting my y value. So I'm going to add 4 to my y's. So I'll multiply them by -2 first, think about order of operations, and then add 4. So -8 times -2, I'm using my y values over here. -8 times -2 is +16, plus 4 is now 20. -1 times -2 is +2, plus 4 is 6. 0 times -2 is 0, plus 4 is 4. -2 times 1 is now -2, plus 4 is 2. And then 8 times -2 is -16, plus 4 is -12. And I now have my new transformed points that have been shifted right, reflected, vertically stretched, and shifted up. So I'm going to go ahead and plot those new points there. Okay, -120 is going to go pretty far off the graph, not a big deal. Somewhere up there is fine. 0, 6, 1, 4, 2, 2, and 3, -12. Okay, and we want to make sure we kind of put these other points in there just so you get an idea of the way the graph is going. Even if it does go off the graph, it's okay. We're just now able to see the shape of the graph. Okay, so then I can connect my pieces together here. And there's my function. Very similar to the parent function of x cubed. It's now just going in a different direction because of that reflection there. Okay, so that is another example on how to graph a polynomial. Remember, it's important that you identify the exponent to identify the parent first using our transformations. Okay, so now you can complete the assignment for today and feel free to ask your teacher if you have any questions. Have a good day.